Welcome to section 10.2, part 3. This is the 98th session of the CISSP exam prep series. This part moves from detection into evidence, work areas, and the utilities that keep everything running. In this session, we'll protect the environment that surrounds your equipment. We'll answer several questions. How do you store digital evidence so it holds up? How do you design work areas by sensitivity? Why is clean, steady power such a big deal? What power problems should you be able to name? How does electrical noise creep into your systems? And how do you keep temperature and humidity in a safe range? Why does this matter beyond the exam? Because the unglamorous utilities are what quietly keep the business alive. Think of a law firm preserving case evidence, a trading floor that cannot tolerate a flicker, and a manufacturer whose shop floor servers bake in summer heat. Each one fails in a different way if you ignore power, cooling, or evidence handling. When you get these fundamentals right, systems stay up and investigations stay defensible. When you skip them, you lose data, uptime, and sometimes the case itself. So, how do you store digital evidence so it holds up? By keeping it isolated, tracked, and provably unchanged. Evidence storage is no longer just a police concern, because every organization now gathers logs, drive images, and machine snapshots for investigations. Keep that data on a dedicated system, separate from your production network, and take it offline when you are not actively adding to it. Block internet access to and from it. Log every action taken on it, and limit access to your security administrator and legal counsel. Encrypt everything stored there, and calculate a hash for each dataset, so you can later prove nothing was altered. That chain of care is what makes evidence usable in an internal case or a courtroom. How do you design work areas by sensitivity? By thinking in concentric circles of protection. Not every space deserves equal access, so the more valuable the assets inside, the harder that area should be to reach. Anyone can find the restroom, but only administrators reach the server room with the most sensitive assets sitting at the protected center. Separate distinct work zones with real walls. And where secrecy matters, run them floor to ceiling, cutting through any suspended ceiling so no gap becomes a crawl-through. A clean desk policy locks away sensitive papers at the end of each shift, shrinking the chance of casual disclosure. Classify each area like you classify data, control visitors with escorts and logs, and for the highest tier, a sensitive compartmented information facility gives government-grade isolation, often banning cameras and phones inside. Why is clean, steady power such a big deal? Because the electricity from the wall is neither as clean nor as constant as your gear needs. You defend it in escalating levels. A surge protector is the bottom rung, guarding only against overloads, and it cuts power entirely when its fuse blows. A power conditioner does more, filtering out line noise as well. An uninterruptible power supply climbs higher, using a self-charging battery to deliver clean, conditioned power and to carry the load briefly when the grid drops. A double conversion type always runs power through its battery for a seamless feed, while a line interactive type switches to battery only when the grid fails, sometimes with a tiny gap. For whole building coverage, there are large failover batteries, and at the top sit generators, which start automatically and with enough fuel run for a long time. Keep the battery even with the generator, since it bridges the minutes before the generator warms up. What power problems should you be able to name? A precise vocabulary, because the fix depends on the fault. A fault is a momentary complete loss, while a blackout is a prolonged one. A sag is a brief drop in voltage, and a brownout is a prolonged one. A spike is a momentary surge of high voltage, while a surge is a sustained one. An inrush is the initial jolt when equipment first connects to power, and ground is the safe return path that lets electricity flow harmlessly to the earth. One more practical rule: if the trouble starts outside your meter, it belongs to the utility, but anything inside is yours to fix. How does electrical noise creep into your systems? As interference riding along on the power or through the air, noise is any disturbance in the power supply. And when it comes and goes, it is called transient noise. Electromagnetic interference is generated by electric current and can corrupt transmissions on phone, network, and radio links. Radio frequency interference comes from everyday devices like fluorescent lights, motors, elevators, and space heaters, and it disrupts many of the same systems. You fight both by conditioning the power, grounding properly, using shielded cables and conduits, and switching sensitive links to fiber, which simply does not care about electromagnetic noise. Locate the noisy equipment first, then route your cabling to stay clear of it. How do you keep temperature and humidity in a safe range? By steady control, not just cold air. Equipment rooms generally sit between about 59 and 90 degrees Fahrenheit, but stability matters more than any exact number because swings expand and contract components. That oscillation causes chip creep, where seated chips slowly walk out of their sockets and can crack solder joints. In big rooms, hot and cold aisles line up racks so intake vents pull cool air in and capture the hot exhaust, keeping the flow organized. Humidity stays roughly between 20 and 80%. Too much invites condensation and corrosion, while too little lets static build until an electrostatic discharge from your fingertip fries a circuit. Add positive air pressure and good filtration to keep dust out. Watch for plenum-rated cabling in air spaces, and use environmental and condition monitoring to catch trouble before it becomes an outage. So let's bring it together. Store evidence on an isolated, offline, encrypted system with tracked activity and per dataset hashes, so it stays defensible. Design work areas as concentric circles, using solid walls, clean desks, classification, and escorts, with a sensitive compartmented information facility at the top. Protect power in levels, from surge protectors up through conditioners, uninterruptible supplies, and generators, and learn the vocabulary of faults, sags, and surges. Shield against electromagnetic and radio noise, and hold temperature and humidity steady to stop chip creep, corrosion, and static. Nail these utilities, and your equipment runs clean, cool, and continuously. The MCQs covering all the topics and concepts from this session are available on rucloud.com. Practice the chapter-specific MCQs before moving on to the next session. Thanks for watching. If you have any questions or feedback, post a comment below or email us. I will see you in the next session.